In this video, we're going to be looking at the two ways that plywood is attached to the top plates in the various seismic retrofit guidelines. We're going to be looking at the history behind these differences, and we're going to take a look and see which one of the two is the best way to do it. So this first way to do it, we see here in Standard Plan A. You see how here at the nails, we have the nails up here at the top, and we also have nails here down at the bottom. Now this is all the way along the plywood. You see the nailing of the upper top plate and the lower top plate all along here. Now we see this in a few different guidelines, and we're going to look at every one of those in the rest of this video. So if you come over here, this is from this is another way to do it. This is from Chapter A3 of the International Existing Building Code, and you see right here there's the nails in the upper top plate only. Right here, this section right here, that is the lower top plate at the bottom, and this is the upper top plate. So you see there's absolutely no nails right here in the lower top plate. So we're going to look at both ways of doing it and see which one is the best. So this is from FEMA P1100. That's the most recent retrofit guidelines from 2019. And then you can see that the nailing is only in the upper top plate. So this plywood nailing is just like it was for the guidelines for seismic retrofit of existing buildings that was published in mid-1990s. And the way Jim Russell actually originally intended these plywood nailing to be. So you can see it's very clear here. It says provide all required nailing at upper top plate, and you see the nails right across here along the upper top plate very clearly. There are a few nails here at the bottom. There's one here at this lower top plate, one here, one here. It certainly won't hurt, but they're not required. So anyway, what you see here is what Jim Russell originally intended for Standard Plan A. So as you probably noticed, all the retrofit guidelines ultimately referred back to Jim Russell's original work in the guidelines for the seismic retrofit of existing buildings as far as the plywood nailing goes. They all recommend 15/32 plywood. They recommend 8D nails. They recommend 4 inches on center on the nailing, and they recommend nailing into the upper top plate only. And the shear walls can resist 380 pounds per linear foot. Standard Plan A decided to change all of that, and let me show you how. You see here where it says 4-inch staggered spacing typical. That means you go here, 4 inches later you go here into the upper top plate, 4 inches later you go into the lower top plate, 4 inches over you go into the upper top plate, etc. So what you end up with is you end up with the edge nailing as being 8 inches. So we have 8 inches here to here, 8 inches here to here, 8 inches here to here. And when you only have 8-inch edge nailing, the capacity of the shear wall drops down to 190 pounds per linear foot. So remember earlier we saw that the plywood is all nailed at 380 pounds if you put them 4 inches on center on the edges. Well, in this case, they're only 190 pounds, which is a whole lot weaker. Let me show you exactly why that's a problem. So in effect, along the entire upper top plate, you have a nail that's every 8 inches. Now the building code does not even have a table that recognizes shear walls that are nailed on the edges at every 8 inches. But anyway, that's what we got. So the way it would actually work is this is a floor joist. And a floor joist is a part of the floor. It supports the floor you walk on. And what happens is when this slides this way, we want to keep that from sliding. So what we do is we take this piece of metal right here, it's called a shear transfer tie, and we nail it to the joist right here, and then we nail it down here into the upper top plate. Now the upper top plate is only 2 inches thick, or 1.5 inches, usually 2 inches. The nails that come in here are 1.5 inches. So all the nails go into this upper top plate. So what that means is earthquake force comes this way, pushes on the shear transfer tie, that goes into the nails that again are only 1.5 inches. So that force goes into the upper top plate, it pushes it that way. Then that force goes into the nails that are also in the upper top plate. And then eventually, when this piece of plywood pushes on the top like that, the bottom of it also pushes that way into the bolts. So these nails here on the lower top plate, they're not connected to the shear transfer tie. Therefore, they are not doing anything. So anyway, that is the problem with standard plan A. Here's a good comparison for the two types of nailing. On the left, you see what you would find if you use the special design provisions for wind and seismic and the guidelines for seismic retrofit of existing buildings and so many other guidelines that we looked at. On the right, you'll see standard plan A and two other guidelines that are mixed up with that. Let's see what happens when we apply these nailing patterns to a standard plan A retrofit. This table right here is from standard plan A, and it tells us that if a house is 1,200 square feet, it's heavy construction, it needs 20 linear feet of plywood on each side. Now, if it's nailed 4 inches apart on edges with 10 penny nails as intended, we need 20 linear feet of plywood. Now that is 4 inches on center on the upper top plate, as Jim Russell intended, as the special design provisions of wind and seismic recommends it's done, City of Los Angeles, all those different guidelines that we looked at. If those are used, so we have 4-inch nailing on the upper top plate, we need 20 linear feet on each side because standard plan A was designed around a 380 pound per linear foot plywood nailing. On the other hand, if we use standard plan A system, where it's nailed inches apart with 8 penny nails as required by standard plan A, we need 40 linear feet on each side. So just as we saw, 8 penny nailing, 8 inches apart on the upper top plate alone only provides 190 pounds of earthquake resistance per linear foot, and therefore we need twice as much. So we need 40 linear feet on each side, which gets pretty expensive. Here we see two identical floor plans for 1,200 square foot houses that are considered heavy according to standard plan A. Now the one on the left will be nailing in the upper top plate only, as we saw in all the guidelines that we just looked at. And then on the right, we'll be nailing in the upper and lower top plates, just like we saw in standard plan A. Now this is what happens when we do that. When we have the 380 pounds per linear foot nailing, we only need 20 linear feet of plywood on each side. So we had 20 feet here, 20 feet here, 20 feet here, and 20 feet here. So just 20 feet on each side for a total of 80 linear feet. Now, if we nail into the upper and lower top plates, then we need 40 linear feet, because remember, when we do that, the plywood can only resist 190 pounds per linear foot. So here we need 40 feet, here we need 40 feet, here we need 40 feet, here we need 40 feet. And as you can see, in order to meet the requirements that standard plan A has defined for us, we'll need to add, approximately 20 linear feet of extra foundation over here. So clearly this system does not work. I think it is probably clear why it makes more sense to nail the plywood into the upper top plate rather than staggering the nails between the upper and the lower top plates. Now, this upper top plate nailing started with the guidelines for the seismic retrofit of existing buildings, which was put together by some very high-powered engineers. And when I say high-powered, I mean these were people who had, 40, 50 years experience doing earthquake hazard mitigation work. The chair of the committee was Jim Russell, who was very well known in the engineering community for his work in earthquake hazard mitigation. One of the engineers on the committee was John Karyotis, who is, fairly famous in the engineering community. Another engineer named Ben Schmidt, an engineer named Nels Rosalind, who's the one who trained me, and the first two were former presidents of the Structural Engineers Association of Southern California, and then Nels Rosalind, he retrofitted the San Juan Capistrano Mission, and he also retrofitted the Bradbury building in Los Angeles, which is considered a truly priceless building. And if you get online and you look it up, you can see why that is. Nels also helped write this paper on retrofitting hillside homes, and he was really generous with his time. And he taught us how to retrofit hillside homes using a steel bracing system, which I hope the Hillside Home Committee takes a look at. The reason I'm bringing all of this up is because I just want to show you that guidelines and codes they're made by human beings. So there's, people there and they have their prejudices and sometimes they make mistakes, and that's why you never find a code, that is perfect. And that's why they have a system where every year or so they look at it again, see if anything needs to be changed, see if they made any mistakes. So anyway, I'm introducing you to some of the people who were instrumental in the seismic retrofit guideline and code development committees. So these are some very, very high-powered structural engineers who recommended the upper top plate nailing only, and I think I made a pretty good case for why that is. In case you're interested, I also created a 21-minute video that goes through the history of the upper and lower top plate nailing, starting from the guideline for seismic retrofit of existing buildings and then going through 13 different guidelines, going into Portland, going into Seattle, go to Los Angeles, just go to every city I could find some kind of a guideline to look and see how they do their top plate nailing.